When you pull a slice of pizza and watch the cheese stretch, you are looking at a solid, dense structure. But it all starts as simple, watery liquid milk. How exactly does a fluid liquid, mathematically and chemically, rebuild itself into a solid block worth thousands of dollars a kilogram? The process begins when raw milk arrives at modern dairy facilities. Before it enters the production line, it has to pass rigid tests measuring fat content, protein levels, and checking for biological contamination. This volumetric breakdown reveals the first mathematical constraint of the industry. It takes roughly 10 liters of raw liquid milk to produce a single kilogram of cheese. Cheesemaking relies on isolation. You discard 90% of the raw liquid volume to extract only the 10% that can actually form a solid. To force that separation, the temperature inside processing tanks is raised, and selected bacterial cultures are added to the milk. These bacteria consume the native lactose sugars, establishing the chemical foundation for the cheese's eventual texture and flavor profile. Then, a second catalyst is introduced, an enzyme complex called rennet. Adding rennet is a precise application of protein engineering. Rennet acts as a biological glue, seeking out the milk's floating casein proteins, forcing them to link into a rigid, interconnected net. As this net tightens, it traps particles, solidifying the fluid into a jelly-like mass called curd. By introducing these specific biological and chemical triggers, the milk's cellular architecture is reconfigured, forcing a permanent physical transition from liquid to solid. Because this new solid still has water trapped inside its molecular net, it is immediately sliced apart using industrial cutting tools. The moment the steel blade breaches the curd, a bright yellow liquid seeps out of the cut. This is whey. For generations, dairy operations viewed whey as a byproduct, often disposing of it as industrial waste. Today, the economics have shifted. That same liquid is now the primary raw material for the multi-billion-dollar protein supplement industry. Back on the cheese line, the remaining solid curds are heated and stirred, and then packed into heavy steel molds, where they endure sustained physical pressure to squeeze out the final drops of whey. Applying that pressure completes the isolation process, extracting the final water weight, and gives the mass the definitive shape and density of actual cheese. While these freshly pressed blocks now possess the physical weight of cheese, their flavor profile is still underdeveloped. To develop complexity, the blocks enter the aging phase. This requires climate-controlled rooms that maintain specific conditions for temperature, humidity, and airflow. This graph maps flavor complexity over time. Premium blocks are kept in these rooms for 5, 10, or even more years. During this time, millions of microscopic chemical reactions run inside the block. They alter proteins, developing aroma and changing the physical texture. After years on the shelf, expert testers manually inspect, smell, and taste the mature blocks, verifying their profile before they are vacuum-packed or sealed in wax for shipping. The cheese in your kitchen is a concentrated result of microbiology, chemistry, and human engineering applied over years.